Yeah.
Yeah, but when you're working, it's so fun. It gets out stress.
Mm-hmm.
It still gets out the stress, even though it's not the right spelling.
I think I only like curse words if I'm angry. But that's I'm angry. Like never it probably comes out.
I'm thinking to get one of those printers eventually.
Yeah, I gotta get one too. I need to print out a casing for mine. Now that we got the mini board working,
Can
it's gonna be important.
can I talk about my failed experiments a little bit?
Yeah, I
Yeah,
wanted
go
to hear
for it.
about your experiments, Phil. I wanted to hear some
Yeah.
updates.
Yeah, I did, but this week it kind of failed. But I'm just gonna talk about it because it's people might learn stuff. I'm just gonna share my screen. Present share
Yeah,
screen.
dude, I fail constantly. I always learn something from it. We
Yeah,
failed earlier, and I learned a lot from it.
uh,
I
yeah.
think like fail
So
forward, not backward.
Yeah, fall forward.
so
That's
I
funny.
made some calculations. This is the gravitomagnetic permeability that I found using my vortex experiment that I did 2 weeks ago. With that, I can calculate the number of kilogram per coulomb. This is the number of kilogram per coulomb, which is approximately 21,000 kilogram per coulomb. And if if you calculate the linear charge density of an electric wire based on an electric field of 200 volts per meter, then you're gonna get a linear charge density of 4.4 times 10 to the minus 11 coulomb per meter. And with that, you can estimate, you can calculate the frequency of an electric field. You divide it by the speed of light divided by eta, which is the kilogram per coulomb constant that I just found. But the problem is, the big problem is I get 5 times 10 to the minus 10 hertz, which is extremely low frequency.
So,
But
wait, let me slow you down. You said you can calculate the frequency of an electric field with
yeah,
knowing the kilograms per coulomb.
yeah, exactly. It's
As one of your
because
variables is the kilograms per coulomb is one of your variables in your calculation to figure out the frequency of an electric field, and the other
yeah,
variable would be the EMF reading you get off the electric
yeah,
field.
the EMF reading is E. You divide it by the speed of light, and but also with the constant, the kilogram per coulomb, and you're gonna get the frequency.
Of the electric field that
Uh,
generated the magnetic field that you measured.
no, it's a pure electric field. So that's
But
what I was.
you had to measure a E, right? What is that?
Yeah,
Energy.
yeah. I did actually measured it with.
So if
I
if
bought
energy is your variable, what does energy stand for? Is that the magnetic field? What is the energy?
the
Ooh, that's
energy. E
cool.
stands for the electric field. This is a EMF
Well,
meter.
the field that the
He's
electric
trying to
creates
hypnotize me
is a
right now.
magnetic field.
Sorry.
Nothing. I was just saying you're trying to hypnotize me. That thing is cool.
Yeah,
That's your EMF meter.
I'm trying to hypnotize Blue.
He's trying to beam us up.
Exactly.
That's a
Yeah, that's cool. I
transporter.
want to get one of those.
What do you call that thing?
Yeah, you can measure the electric field.
Star Trek walkie-talkie.
Yeah, the magnetic field and the radio frequency. The radio
Transponder.
That's not a
frequency.
tri-field
The
meter. It's something
transponder.
else.
So you're measuring. What does that measure though? EMF or what is it?
yeah,
Measure?
either a magnetic field, an electric field, or
It measures both, huh?
radio frequency
Oh, nice.
It measures
And-
both the electric field and the magnetic field.
separately.
Yes.
Nice.
And what do you get? Different numbers on that?
Yeah. So that's the magnetic field. I don't have a magnet. It's kind of away. But this is the electric field right here. So if I move
But is that a static electric field or is that a dynamic electric field, a moving electric field? Is it,
no,
'cause you could be measuring the screen of your computer right now.
yeah, but it's LCD.
That's a static field. That's
There's
not the
no-
same thing.
Does
That's
it,
not the
it-
same energy that generated the magnetic field, is what I'm saying.
does it
No, that's really the.
Anybody disagree with on go ahead, shoot, because I'm telling you, you need a moving, not a moving, but you need amplitude to generate magnetic field. You can a steady magnetic field. You can generate a strong magnetic field in a pulse using very low amplitude, or what was it, amplitude, but low current, low amplitude, but a lot of voltage, and you're still going to get a very decent magnetic pulse off that.
See, I have a power cord here, and if I put the electric field reader, the meter next to it, then you're gonna measure quite a strong electric field.
Off of
What
your
model
electric
is
cord.
that? I want to buy one.
Yeah, it's like $40. It's called Testman EMF meter.
That's the end of the cord. If you plug something into it and measure where the load is being created, it's a whole different ball game. You're going to get a much bigger reading
Yeah,
and a much bigger magnetic field there at that point too.
That's cool though. That
Yeah.
is really cool.
and that's the electric field. I'll show you for the magnetic field one sec. Well, I gotta be careful with.
I mean, what I think understand is when you create a load, you're going to have at that point where the load is being transferred to the load itself from the source, you're going to have a lot of magnetic field going on.
That's a magnet right here. So it measures the magnetic field now.
Nice.
What are you measuring? The light, the flashlight?
He's got a magnet in his hand.
Oh, magnet. It's a magnet.
Yeah, that's a magnet. And
And measuring the gauge magnetic field, right?
yeah, the Tesla or the Gauss. There's two modes. And I can also measure the RF, the radio frequency signal of the Wi-Fi is pretty strong. If you measure the radio frequency of the Wi-Fi box, it emits a lot of radiation. So wherever your Wi-Fi box is in the house, you better be far away from it because it's pretty. There's a lot of radiation coming out of it. Even the cell phone. See 1 second here.
Yeah, that's because they turn up the amplitude because they don't want to have any drops in the signal. They can turn down the amplitude, get their tuning better, and they don't need all that power.
Even the cell phone. See. So 1 sec.
What I'm saying is that they got the tuning down so well already, with cell phones.
So that's my cell phone, and see, look at that. That's the radio frequency of the cell phone.
Right. I just think they turn the amplitude too high. I heard that on the towers they turn the amplitude up too much on the transmitter.
So the cell phone emits a lot of radiation.
Like for them, it's a cost benefit for them to turn the power up because they don't pay a lot for that compared to what they make.
Yeah,
so they turn the power up on their transmitters so they don't get any complaints from nowhere. or whatever, But at the same time, you know, they, yeah, they can turn it down to the right level, and the signal would be even better. But
Actually, look at that.
it's a lot of work to tune all those transmitters and get
Yeah,
the amplitude just right on all of them.
yeah. Look
And
at
then
that. I'm gonna turn the personal hotspot on. There you go. It's
they're going to
on.
one day develop an algorithm or something to run these transmitters remotely on their amplitude to
So the
adjust for the
personal.
weather and all kinds of things like that. All this stuff is new, man. This, wireless stuff. I mean, Tesla came up with it 100 years ago. Now it's blowing
Look at
up
that.
like everywhere.
That's
Being used in every way.
the radio frequency of the hotspot of the cell phone. A lot of radiation coming out of it.
But Tesla was using lower frequencies. He wasn't using high frequencies. He was using FM for his boat.
Yeah, and I also bought a low frequency, like you were talking about, the low frequency radio that I bought last week. I wanted to measure the frequency of the electric field in a magnet, but it turns out I made mistakes in my calculations, and the frequency I'm expecting was way too low. So
Yeah.
yeah, it's way too low. So I'll just
I mean, FM is already megahertz. That's high enough. You don't need to go into the gigahertz, but they do anyway.
yeah. Actually, here's the experiment. I'm gonna.
If they go into the tetrahertz, there'll be, those towers will be beaming out light rays because that's close enough to light.
Yeah. So that's around 80 kilohertz. The line, the vertical line you see on the screen is around 80
Screen's not popping up.
kilohertz. But now I'm hovering power cord next to the antenna, and you see the frequency spiking on the screen on the right. Every time I hover the power cord very close to the antenna. So I thought that I had the right frequency, but it turns out I don't. I didn't have the right frequency, so I made the wrong calculations, and uh, so but I wanted to solve the I wanted to solve the exact value for the gravitomagnetic permeability this way, but turns out the frequency is way too low. And I also have like a RTL SDR adapter. That stuff here. Anyway, it's
Are
gonna
you
be
looking for a diamagnetic effect or something more concentrated? Or both? Because, in the center, you could probably get a concentrated magnetic field. And then the outer perimeter, you can get the diamagnetic effect.
yeah, but the diamagnetic, it's no, I just wanted to measure the
It's like
frequency.
the water. The water is like diamagnetic. It's lightly magnetized.
Yeah.
Stuff that's
No, I
easily
just
lightly
want to measure
magnetized.
the frequency of energy density field. That was my goal, but it turns out it's way too low. So, yeah. So
Well, technically speaking, if water is diamagnetic, and you got water in the air, and if you have a device generating a field, I'll stop there.
yeah.
And which test was this for? Was that for the water test with the two tubes we saw last time?
The MHD, right?
No, there was an independent test that was not related to the electrolysis or the MHD vortex. Just
Oh.
an independent test.
Oh, different thing. Okay.
Yeah. because it's related to the same maths behind. I wanted to solve the gravito-magnetic permeability.
Right, you're
I
using
already
the
have an
MHD for your
idea, but
gravity experiment.
sorry.
Yeah, and that's where the MHD is. You're using that for the gravity experiment part of it.
Yeah. I'm using it, but I just wanted to try to solve it differently. But I failed, man. I failed this week, but yeah, I
How did
still
you
learn
fail? What
this.
in the calculation, or what? Where was the failure here? I don't get it.
No,
In
I
the
mean,
in your
the
math didn't come
frequency
out the way you thought it should, or what?
my equipment is not sensitive enough.
To get to the numbers the way that you needed?
Yeah, like 10 to the minus
Oh,
8
okay.
hertz is way too low. I thought it
Well, that's
was
not a failure.
80,000.
That's just that's your manufacturer failure there, if you ask me.
Yeah, but I learned a lot. I mean, I learned how to read these low frequency waves. I learned about RTL, SDR, all that
Well, you're
stuff.
talking about a frequency that's like one pulse every 100 years or something. It sounds like very slow frequency.
Yeah, exactly. It's very slow. But apparently
That's
that's
strange. That is strange. To
the,
think that
the,
that's
the
actually existing. Like a pulse every 100 years. That kind
yeah,
of stuff happens.
yeah.
In our time, Earth time, every 100 Earth years, and it happens not on Earth. Somewhere else.
So technically, we can say
The
that
relativity of that boggles the mind. Like how do you differentiate between like that long time distance in time between compared to a short one? Like how
If you
I
think
don't
about
know.
a
It's
frequency that
hard to
low,
know.
it would go very far through the cosmos because it's.
Yeah.
I don't know how to explain it. It's like it's very low frequency. So
I'm
you
just
send out one
gonna
shock wave, and it goes and goes and goes. You time it right, and you send out the next shock wave, and it goes and it goes and it goes. It's because it's such a low frequency.
How do they know?
Yeah, that's
I'm
crazy.
ju- guys, I'm just gonna scoot out for a quick smoke. I'll be right back.
Okie doke.
How do they know it's every 100 years? I mean, we haven't had the technology to detect.
I'm just guessing. I don't know that. I mean, he said it was one to the frequency you were calculating was one to the power minus something.
minus something.
10 to the minus 8 hertz.
I don't know what that is, but that's a very that's like one pulse every. I don't know. I'm just guessing like 5 years. I don't know. It's a very slow frequency. It's not 7.4. 7.5 hertz here on Earth is 7.5 pulses a second, not one pulse every 5 years. So you can kind of look at it like that. That's how slow of a frequency he's looking to.
Yeah. I mean, so technically, you can say that the electric field and the magnetic field barely have a frequency or have none, but there's still
it
a
sounds
number.
like hard to calculate something like that.
Yeah. But I still learned a lot. I was optimistic because I did use ChatGPT to have estimates initially, but ChatGPT led me into error. So, I thought ChatGPT would tell me that the linear charge density was 15,000 coulomb per meter, but it turns out it's 1 times 10 to the minus 9 coulomb per meter. So there's an order of magnitude difference of 14 digits here.
We always have.
So
You definitely
You
need
gotta
a
be careful with
calculator to
chat.
follow any of this stuff he's saying, but he's been following it himself on the calculator. So I'm telling you
Yeah.
that.
You know where
I had
did
a similar error with ChatGPT and the calculations for the battery earlier.
yeah, it's frustrating because you need to you need to understand the error of ChatGPT and figure out where it is. So it's just faster to calculate it on your own, and and it was not even doing it the correct way as well. So you got all in math ChatGPT. It's even ChatGPT 4. Right now we can they shared ChatGPT 4 for a limited period of time every day. and it was 4, and it led me into error. So I'm gonna. It's good. It's good for to do when you're confused on something. It's gonna clarify things, but in mathematics and science, it's very annoying when it's doing mistakes like that.
Are you trying? Which mode are you in? Scientific, engineering?
There's no modes. It's just ChatGPT.
Oh, I mean, I meant with your calculator when you're doing those calculations.
Yeah.
Using engineering or scientific? Scientific will get you the more accurate reading than
Yeah.
engineering will.
Yeah, you use Maximo like you saw at the beginning of my presentation. I really love WX Maximo. It's written by MIT, and you can do calculus and a whole bunch of high precision calculations and stuff. So it's pretty good. So what's up, Nathan? What have you been up to?
I'm just trying to hold on right now. It's
Oh
just,
yeah.
yeah, it's all come flying at me real quick. It's, between doing the shows and then my granddaughter's over here all the time. So I have zero time for myself anymore. So, yeah.
Just start drinking and you're gonna forget your stuff. And no, I'm just kidding.
Yeah, no, thank you.
I'm just kidding.
I don't,
Like I
yeah,
don't want to be a bad influence, but just kidding here.
yeah, no, I get it. But no, it's fun, man. I had a chance to go over some schematics and stuff that we were working on in the workshop. So I put those out. People are asking for it. We're doing a stereo circuit, so I had to go back and look at everything and figure it out, put it together. You know what I mean? Stuff like that. I've been collecting stuff. I've been out running around. I got a stereo receiver and I got the magnet. I built my rodent coil. So I'm about ready to catch up to Ben real quick here on what he's doing over there. And
Are you there, Ben?
yeah, I don't know if he's there.
You
So
fell asleep,
Yeah, I'm
did you?
here.
but yeah, I'm about to catch up real quick to him and get all the experiments that he did real quick. Just some of the circuits I don't have all the parts yet, but that's okay. I'll just make do with what I have. So yeah, about to start running frequency in this thing, see what it does. So I expect we're going to get some good numbers out of it and finally figure it out because I'm going to find the resonance frequency of it. And then I'm going to see exactly how to pull in the load so that we can get this thing to multiply better than it has been. So should make everything easier, including spinning the magnet.
Yeah, because I'm stumped on the big one, the Fireball. Like I've been messing with it, and I think I need to hand it off to a more experienced electrical engineer.
Well, I'm gonna run that sucker on DC first, and then I'm gonna give that sucker a resonate real quick, and then I'll.
Yeah, well, I was just gonna say there is a way to make it run really good on DC. I just I haven't cracked it yet, but I'm sure you'll be able to, or at least give us some insight.
It's all in the frequency and getting it right. Yeah, I'll be able to do that.
Mike said to adjust the duty cycle. I might do that later tonight and see what happens, but he said to adjust the duty cycle so it's 90 high and then 10 low. So
No. 90 low and
90
10
low and 10 high. Yeah, so I might do that at some point tonight just to see what happens. But yeah,
I'm just gonna take the duty cycle on the little Amazon deal and go up and down on it. So it's real quick, no programming, no nothing. Just plug it in and play it. So
yeah, you just have to
so much easier.
Sweeping it, yeah.
Yeah, no, thank you. Well, I'll sweep it with the radio frequency first. Put a 20K resistor on it, and then we'll sweep it, and I'll find out what the resonance frequency is. And then once I find the resonance frequency, it should be fairly simple and exactly what goes into this thing. There's no guessing at that point.
Yeah. Once you have the resonant frequency, then you can learn to manipulate that signal.
Yeah, I'll be able to change which wires I want where in order to get what I want. So it'll be pretty nice.
Yeah, and I got a board for you that worked out well for us. I don't know if you saw it tonight, but it's a it's only like $23 on Amazon, but it works pretty well, and it's really small. So if you're looking to do like a more portable version of the stereo amp, it's a pretty good alternative.
Nice. Well, I went over Gerald's exact schematic, and I
Mhm.
put out a video on it so everybody understands what he was doing.
Oh, the
And
stereo amp.
yeah, he's using the transistor as as how do I say this? It basically will blow up the transistor before heat gets back to your amp, is what it's
Can
doing.
you
So
can you bring that up? Do you have a picture that you could bring up real quick, or you said it's on a live stream?
let me see. I could probably share it real quick. Yeah.
Yeah, because I'd be interested in taking a look at that because I probably have all the components or most of them to build that and test it out tonight at some point.
So let me share it real quick. You see it? Or Mike's got it.
Oh, there we go.
That's not it.
What are you looking for?
So the stereo amp circuit diagram, I'm going to take a look at it, see if I have.
There you go. That's what Gerald built.
Oh, I do have the 13009. I knew I ordered that for a specific reason. I probably heard Gerald say it.
Yeah.
Yeah. So I knew I had that transistor for a reason. So I have
Yeah.
that transistor.
So I basically just went over the flow of the actual circuit, and he's using the transistor in a different way. It's just to take the back EMF so that it can take it and blow it in that transistor before it gets back through the resistor to your stereo amp. So
Oh, that's interesting. Yeah, you could do that.
This is the,
It's like a
this is the
fuse.
protection circuit.
yeah, that's what it is. It's not so
So-
much of it's
You
not
just did
so
like a
much.
fuse.
There you go. That's exactly what he's doing. So the idea is to catch that back EMF spike and it'll blow before your amp does. So
You can get
Yeah.
transistors for under 40 cents, 30 cents. Get them in bulk, you get them real cheap.
yeah, but it's an easy way to do it instead of blowing stuff up. That's kind of the main goal here. And it's not to amplify the circuit or anything else. Your back EMF that's created because of where he puts the power in will automatically amplify the circuit.
Is that a diode on the very left between the coil and the resistor?
Yeah, I drew the arrow so you see the X. It just says that it can't go back that way. It always has to flow
Okay.
around the other way.
Do you have a preference on which kind of diode I should be using there, or does it not really matter?
The transistor is 400 volts, and I believe it's a 15 to 30 amp. Okay,
How
But-
much is that?
it's 150 Celsius on the temperature, so it's going to lower both those numbers.
Mhm.
So you have to watch that. So
How much is that transistor, that 400 volt?
how much what?
How much would that transistor cost? The 400 volter.
I don't know. I didn't look it up. I was just trying to get the circuit out for people so they can look. I had to look at the specs and see, you know what I mean, how far it go. But it's enough to handle a Bedini spike. So when you get the back EMF, it'll handle that.
Sounds like a
And
MOSFET.
then when it gets too much, it'll blow.
So yeah, I have everything to build this. I'm gonna build it tonight and see how it works because I need some kind of protection for that mini board because
Yeah.
it's a mini board. It's not gonna be like have all the protection that's built into the stereo amp. So this would be great. But again, to the diode though, is there any preference of like which? I have a
about
whole
the
box of different
protection for the
diodes.
stereo, you need to get the NE-2 neon bulb and put that. That's 120 volts. It requires 120 volts for anything.
You
to
know,
go
I
through it.
have a neon bulb that came with my Tesla coil somewhere. I just gotta find it.
I just
so-
know that, guys, it's a known circuit. Gerald used it. It worked. Okay. And
Yeah, I'm just wondering which kind of
The
diode.
neon
to
bulb will
grab.
do the same thing
I'll
that
grab
Gerald was using the transistor to do. Only thing is, it will act like an indicator. You'll see when it's.
well, I'm just saying, this is what he gave us. So that's what I put out there. I followed the flow chart, and this is what
He
it
was
is.
using it to protect his thing from the spike, huh?
Yep. So from that back EMF spike you get, he's
Well, I
using
can
it-
tell right now he's never
protect
replicated the Bedini because if he had, he would have just used the NE-2 bulb.
He did. Okay, hold
He
on.
did.
Hold on. He did at a later time do the Bedini circuit. But
Oh,
this
so
is
he
the one he
figured
used before the Bedini circuit. So we're just following his timeline on what he gave us.
wait a minute. Yeah, you
Oh,
want to
he
use
was
that
using
bulb
the SG.
for that.
He was using the solid state, right?
I don't know which one to use. He didn't present it yet. I'm only trying to work backwards so that I can bring everybody up to date because Ian was really on Gerald about this. So I want to make sure I got it out for him.
Yeah. Okay.
But
I have a diode.
it explains
Okay.
why the collector's not used. Basically, when you look at it,
Mhm.
he doesn't use the collector at all because he just wants a one-way diode, but he wants to be able to temperature control the circuit.
Zoom in.
So I have a 10 amp diode, 1,000 volt, the 10A10. Do you think that would work? I think that might be the one that I
Yeah.
choose. Yeah.
Yeah, that would work.
Yeah. I just don't want to. I don't want to leak out or blow or whatever.
No,
Well, if you blow a diode, it's a couple dollars. You know what I mean?
Yeah, exactly. Not even that.
What's that thing on the
Oh.
right? Not in red, the black writing. The thing on the right. I see diode coiled transistor. What's the thing? Oh, the battery. Is that the battery source?
Yeah, there's no battery on this. It's just a stereo amp.
Oh, stereo. Okay.
Yeah. So there's no batteries according to it. There's no extra power going in this. This is simply the
Emitter.
power of the stereo amp.
Oh, you put the transistor in line on the negative.
Yeah. Look
Yeah.
at those big boys.
Yeah. So anyway, that was it. Just kind of what I was working on. I had time today to put it together so that we can get it out there. That was it. It was kind of I was spent all day watching my granddaughter, man, and running around after baby is tiring when you get old. I can tell you that right now. She moves way too fast.
Mhm.
Yeah, and they don't stop. They're like the Energizer Bunny.
Jeez.
Never run out
Never
of energy.
stops.
You want to see over unity?
The thing about the neon bulb is that nothing will go through it unless it has 120 volts or more with it of voltage. So as soon as the flyback, tries to go to your stereo, it's going to be over that voltage, and it will go through the neon instead of the stereo. And the neon will light up and you'll see it, and you'll be, oh Jesus, what am I
Yeah,
doing
but
here?
you're talking
I'm
about
running
much more.
flyback back into my stereo. I better figure this out.
Yeah, but you're making a more complicated circuit than what it was.
It's
To
just a
do
light
that.
bulb. You put it across the two terminals, and it protects those two terminals from anything high
But the
voltage.
light bulb's also a diode, right?
No, it's a
That was not?
Ne-2 high voltage neon.
Okay.
It's what the Bedini uses in his circuit for that, to protect the transistor from getting blown out by the flyback.
But the point of
So-
the circuit was to blow out the transistor before your stereo.
Yeah, well, this bulb doesn't blow out. It just keeps going, lighting up and protecting the transistor, so you don't have to keep changing it.
Okay.
It's a little bit more attention. And it's only, you get like 10 of them for $5, and they're not easy to burn them out.
So it has like a minimum for it to work, but the much higher max of
The minimum voltage it requires to pass any current through it is 120 volts,
in the max.
1,000 volts.
Oh, okay.
It's just anything over 120, and it will allow current through it and create some kind of light. Very interesting light it creates on a new bulb. It looks like lightning, but after it burns a little bit, I don't know what gas is in there, but and then it turns like a yellow orange.
Here's my print that I just finished.
Nice.
It turned out great. I'm doing the second half of it now. That's like an hour and 50 minutes. So, yep. So far, so good.
It's used to protect the transistor. It's just a 2-terminal filament bulb, 2 terminals across the emitter and the collector. And if you disconnect the charge battery, that light will go off because in the Bedini circuit, the charge battery is there to funnel the flyback into the charge battery. So as soon as you disconnect the charge battery, the flyback is going to be hitting the transistor, and the light will go off if it's connected across the transistor.
Now, yeah,
And
Gerald
it'll-
says that's exactly what a circuit was designed to do with what I was saying it did.
Yeah, there's
like
many
that
ways
green,
to protect
Mike.
your circuit with a fuse type device, but Bedini chose the NE-2 bulb probably because he didn't have to keep replacing it every time it burned out. It kept running and kept protecting the. I don't think it's anything particular about the bulb other than that, that it doesn't burn out. It's not easy to burn out that bulb.
That's because it's a load. He's putting a load on the system, and we're not trying to use that. We're just trying to bounce it.
No, this bulb doesn't have much of a load to it. It's got a very high resistance and it's a very small
Man, our
light
live
bulb. I
chat
don't
is
see
hot
it.
today.
It's not very bright either, so
Live
it's probably
chat's
can
smoking.
handle a 1 amp before you burn the bulb. Maybe.
Look at Gerald. Oh, always something.
I don't think I've ever burned one. I got a bunch of them. I just, when you take a circuit apart and the leads get too short on the bulb and it's just hard to resolder it, so you just. But I've bought a 50 pack for $10. It went through half of that already. I still got every one of those neons in different boxes and mixed in parts, and they still work. I'm sure of it. Just, yeah, they're not easy to burn them out. I don't know why, because they don't take a load really. They take the height. They take the voltage.
Yeah.
Voltage. I don't know how to explain that, but they don't really take much current. But you could throw all the current you want at it. It's not going to take it because it's a very thin gauge coil and it's not demanding any current. So.
Yeah, it might not work for this then because the whole circuit's designed for it to over amplify and blow up. That's what the circuit's designed for.
That's the flyback blowing stuff up. It's not a high amperage to flyback, but it's a high voltage and it will destroy microcircuitry anywhere in the vicinity. And
remember the last high voltage I put through one of these things, man, it started shooting sparks out like 2 inches long. It was great.
Yeah.
Use the variac and just crank it up, and it just boom, and it right at you, and you're like, yeah. You wanted to get out and videotape it, but you knew responsibly you had to stop and put it out. But I should have left it going. I would have loved to capture that. So.
Yeah, analog systems they're very durable.
Oh man.
When you start putting switches on things, that's the first thing that's going to go is the switch or the fuse or whatever. Fuse is the switch.
And so, yeah, when you're I was filming this one time and I was because you're looking at it through the screen, you're not actually looking at it with your eyes straight up. So I noticed something was smoking and I didn't notice it right away. I'm like, is that something smoking? And then it delayed my reaction.
Well, hey Ben, it should also tell you what blew up in your amp. When you look at it, to look on the negative side of it and see what's behind it. I bet you're going to find a couple resistors and a diode dead.
Yeah, you're looking at it going, oh no, oh no.
Well, if the flyback hit it, you're not going to really see smoke. But if this is,
he's not working with a flyback. He's working on that coil, and that coil's back EMF is like total pressure. It's just
maybe the coil drawing too much current, and that'll burn out something.
Insane.
Well, what'd you do? Throw the gain all the way up on that thing?
Yeah, and you know what? It blows.
He keeps turning it up.
Well, the energy generation tests are fine, but specifically when I start messing with the neodymium sphere, because the extra energy I think that's created by it spinning is also adding to the back EMF, and I think it's just too much for it.
Because you're making a motor and a generator at once, and you're not pulling a heavy enough load to pull it out.
Exactly. It's not connected to anything really. Nothing significant, at least. No, you're absolutely right. I had the same thought.
Yeah. It'll be fun.
Yeah, no, these coils are fun to experiment with. I'm sure you're gonna have lots of fun with yours and show us some really cool stuff. I'm excited.
Yeah, I had to go get some more tube TVs too. I had to go raid some people to get them so I can get some more flybacks because I don't like the new ones that they put out. They're too stiff. They don't. They're not been broken in enough.
You're telling me the new TVs have flyback?
No. I mean, like when you buy them from Amazon, the flybacks, they're not used enough.
Oh,
So they're not.
I don't think
They
new
don't
TVs
break
have
down
that.
any bit. They're too powerful. I
Yeah.
like the ones that have been used a bit, so they're kind of old. Then you get
Shouldn't be
the
able to
better
find those new
voltage.
TVs, just the old.
They're just easier to manipulate. Let's just put it that way. So I bought two that were new, and oh man, it was the worst experience. I won't ever buy that kind again.
Old man builds, old man volts.
Yeah. Well,
Maybe the new ones have
they
it.
couldn't handle it. Is what the problem
Yeah.
was, and it starts sparking over the bottom. All I get is fires. So
That's interesting because that's something I would never come to like. I would never draw that conclusion. That's not something that I would have thought about. Like that's the reason why, it's too powerful. It needs to wear a little bit.
yeah, well,
It's interesting.
basically it needs to build up some carbon in there a little bit, and then we'll be all right. Get a little resistance, and then I'm about where I want to be. So
No, that's interesting. That's awesome. I just it's the last thing that I would have thought of.
well, when you're trying to pull straight charge out of one of these things, man, it's the most important thing in the world. You don't want those amps in there. You want them out. You want to create the dielectric between the two power lines. So you're looking to get as many amps out as possible so that you can get that field. And that field, man, once you get that, that's what you want. So
That field of just pure potential, like you said.
yeah, well, it's the dielectric field that they were talking about. So it was Steinmetz and how he built the power lines and stuff like that. And that's exactly what I need because I need pressure. And that's the pressure I'm going to get with it. So I need some good flybacks because the last ones I had, it melted from the inside out.
Wow.
So, well, you start frying things with them, things happen.
Are the fly one size or different sizes?
They're different.
They're different.
Every one of them. Yeah. The ones that go in certain TVs are built for that TV. So you'll notice as soon as you open it up and you see a circuit board and you got a 200 volt, capacitor sitting there. And then when you get to the monitors for TVs, the old school ones, the monitors, the big ones, they were 400 volts. So your actual flybacks can run differently. So you get one massive dose on those other ones. If you could have connected to the monitor directly, you get a massive, it'll stop and then boom, it'll hit, right? Where the regular TV, you put them close and they give you that nice, you know what I mean, voltage in the purple and stuff. You pull them apart. Now you got a big charge in the center. And now you can put something in there to move it one direction into the other. So.
Those things are not in the flat screen TVs, the newer TVs.
No. They don't need them.
I think maybe they might have them. I don't know.
No, they don't. I tell you, they don't. I have some that I opened up just to find out was them, and they weren't in there.
Because I have a couple.
Oh, you did? Okay.
If you guys have access to the old tube TV, what you do is you set it up so you get basically like the white screen with the fuzz.
Mm-hmm.
Take a magnet, put it right up to the screen of the TV screen, and you'll see the lines of force of a magnet show up on the screen.
I've done that as a kid. I messed up so many TVs.
Yeah, it will eventually screw up the tube. But if you have access to old tube TVs, you can put magnets on there and you could actually see the lines of force going around the magnet. It's really awesome.
That's all it takes to just turn it on and then take the magnet to it?
Yep.
Oh,
Yep.
well. Give me just a few minutes. We'll see if it works.
Yeah, you're going to ruin that.
I'm going to do it right now.
It'll probably fry it. But
Yeah.
Will it fry my flyback?
Probably not the flyback, but it could ruin the tube.
I was gonna
Like if you
about the two.
like if you hold it there too long, it probably will do damage.
Well,
but
let's
just
give
for
it
a
a few
couple of
seconds and try it. I always like
Yeah.
blowing something up. Give me a minute. Let me set it up.
All right. Yeah.
I did not know Nathan had a daughter. I didn't.
You're getting
You're
choppy
breaking
there.
up there. Say it again.
I said I didn't know Nathan had a grandmother. I didn't see that.
You're choppy.
You're all choppy. Say it again.
You're walking around. That's what it is. Oh no, you're not. Okay. Yeah, there you, I don't know. The signal's choppy.
Can you hear me?
There you
Yeah,
go.
that's better.
Yeah, I was saying I didn't know that Nathan had a daughter. I didn't think,
It came through pretty good there. What's he trying to blow up now?
the TV.
He's going to put a magnet up to the old style tube. It will show the lines of force when you turn it on and you put it up to like the white screen, like where it's fuzzy, or even a dark screen. It will show the lines of force of the magnet, the
The gray.
magnetic field. And know who used to do this? Floyd Sweet. He used to do that to tune his magnets for his vacuum triode.
Or wasn't he trying to detune his magnets a little bit?
Well, reprogram them or something like that.
I think he was trying to
Said
create
he
a
was
weak
tuning them
spot
how?
on the magnet.
Well, he was tuning the magnets. He was basically killing the magnet and then reprogramming it the way he wants.
Look, he's got
Okay, here we go.
Ooh.
All right, hold on. Let me put you full screen here. Hold on. Let's go solo here.
We're gonna watch some family video soon.
So we got a neodymium magnet.
Yeah, don't do it for long. You seeing anything? Try changing the station.
Oh, hold on. I'm seeing a little color. Hold on. So what do you want me to change it to?
Try that. Try
Yeah,
try
the
this-
white.
the white fuzz.
Yeah, the white. Try the white fuzz. Okay, put
I
it
think
up.
it's to
You
be
can
a
see the
black.
Oh,
color.
there we go. Nice.
Green.
There's the lines of force of the magnet right there.
Yeah, you can see the color change, huh?
Yeah.
Go to a channel that's black screen.
Try black. Try a different station. Darker the better, maybe.
I can see it. You
Can
can see it following it. Yeah.
Yeah. So there you go. There's the line. Do you have a bar magnet? Try a bar magnet.
Well, Neos have a very short field, but they're strong field. A regular magnet.
Try to look at the lines of force going around the bar magnet.
Yeah, you should be able to
Oh,
tell.
hold
the
on, hold on,
polarity
look
if
at
it's
it.
clear enough.
Look at it when I turn it. You can see it.
Yeah.
Yeah.
Yep.
There you go. Okay, children, don't blow up your grandma's TV.
That's so cool. Thanks, Mike. Oh,
Nathan
there you
told
go.
us to fry it and find out.
That's
That's
right.
what I'm gonna
I
do.
taught everybody to destroy your tube TV.
No. But if I get an old one, I might do this experiment. This is
Hold
cool.
on.
Very cool.
Yeah, we'll just amplify the magnet. There we go. I put more magnetic
Yeah.
force on it.
Nice. You
Cool.
know what we could do, Nathan? We could use this to see how far the rodent coil's magnetic field extends.
Yeah, well, this TV is not going to last that long.
Oh, not maybe not.
Yeah.
No, not this
Yeah,
one.
don't do it for a long time. Don't want you to blow it up.
Oh, man, that's fun.
You like that?
Very cool.
So Floyd Sweet was doing that after he retuned his magnets. He would put them up to the TV screen and see how he changed the force of the waveform, right?
Yeah, you want
So you
to
can
So-
pulse a
like
magnet just by putting it up there?
Hold on here.
That's crazy. I never heard of that. That's awesome. I gotta try that.
Yeah. Yeah, very cool stuff.
Who did we lose?
Um, Nathan. Yeah, Nathan dropped out. He'll be back. Hopefully. I mean, I dropped out
Maybe
earlier.
maybe his magnet hit the computer.
Oh, I hope
exactly.
not.
Oh
Hope
no!
not.
He
No.
demagnetized his
Oh,
computer,
man.
his hard drive.
There.
No, there he is.
Did you-
Okay. You scared us, Nathan.
You thought you fried your computer with a magnet.
no. This thing's taking a lot more abuse than that.
He's got that thing in a Faraday cage by now.
Oh, this thing
Right.
it tells you when it's upset because they keep dinging all the time when I start doing experiments. You always hear it in the background. I'm like, okay, I get it.
Yeah, so like what I was saying before, Floyd Sweet was doing that when he would bake his magnets. So when you heat up a magnet, it kills the field. Then he put it in the column tube with the coil, drop the magnet inside, and remagnetize the magnet, the ferrite magnet. Then he took the magnet and put it on the TV screen to see how he changed the field. Now, what he was looking for is not just the waveform, but it was now in motion. It was actually moving that waveform.
Oh,
So
nice.
basically, right. So because of the ferrite magnet, he reprogrammed it to oscillate.
There you
When he
go.
put it on the TV, you could see the magnet doing this,
Yeah.
oscillate.
So
And
it's like
then he put it in the system and ran it.
That's cool. All right.
Yeah. He was doing that back in the early 1980s with John Bedini.
Nice.
He was, yeah,
He had to demagnetize it first, though.
yeah. He heated up the magnet. When you heat up a magnet, it loses its magnetism, right? That's
right.
pretty much a well-known fact. So
That's-
after he did that, he dropped it in that cylinder. Basically, it's a big coil of wire, and started magnetizing the ferrite magnet from 0 to whatever he wanted,
Nice.
right?
Yep. Yeah, that's why high voltage and magnets don't work well.
Yeah.
So
the heat demagnetizes them from
Yep.
the high voltage.
Yeah. Any magnet, if you heat it up, it destroys the field.
Yeah, I knew that. Yeah.
But if you heat it up and cool it down again, is it going back to normal?
No.
No, it loses. No, you have to remagnetize it after that point.
Oh yeah.
I saw this called a magnetometer. It's like a machine that you put any weak magnet and it turns into one of the most powerful things. Like it just yeah. Yeah.
Yep.
It's a cool machine. I mean, I would want one. You can make pretty
I'm
much.
Nathan, I'm surprised you added Tube TV kicking around.
I told you I need some flybacks. I need. That's where I get them.
Yeah.
I go around, see who's got them. You know what I mean?
Yeah.
Could be yard sales, stuff like that. You got it,
pick 'em
man.
up
I'm
for
on
like
it.
$5.
Yeah,
Pick them
I
up
get
for like $5.
about $20 sometimes. Yeah, sometimes
Yeah.
0. Sometimes take all of them. You know what I mean?
Really?
And I'll pick up stereo amps the same way. You know what I mean? Anything that I need, I love yard sale shopping for this stuff because they just want it gone. And
Yeah,
I need to. I always need circuits. Yeah.
One
Yeah,
man
my wife's
rub another treasure.
Oh, by the
Just
way,
want it gone.
I registered on Amazon Prime, so I get my pieces like within 24 hours. It's pretty cool. because I had there was an electronics store, by the way, Mike, in Montreal, but it's pretty far
Oh yeah,
away. So I got tired of walking around, so I just registered to Amazon Prime,
right.
and you get it pretty quickly. So just by the way, if you need stuff quickly, then it's suggested for you.
Yeah. Well, I got that surplus that's not too far from me. Plus, I got Sale Electronics and A1 surplus. So I'm lucky that I live in a pretty good area where I have access to this stuff if I need to.
Yeah.
And last resort's AliExpress or Amazon. But,
Where
Yeah.
did you get your Raspberry Pi board from?
this one was my partner that I'm working on the Cell project. He got it on Amazon.
Oh, okay,
So
there you
yeah, it's like I think it's $329 for the newest one that I have. It is. I'll show everybody again. It is the
320.
Raspberry. Yeah, it's Raspberry Pi 5 starter kit. So it's
You're
got
saying that
everything.
the Adreno can't do what this thing does?
Well, this is just a different kind of Arduino. This one's Raspberry Pi. They kind of do the same things, but I think the Pi has more features. Like I know the Arduino, you can't really hook up a monitor to it, where this thing it has like a S video port, so you can plug in any S video monitor into it.
Yeah,
So
the
and
Arduino isn't as versatile, and the Arduino is only limited to 5-volt output as well.
right, where this thing's got like huge options on it. Like it's totally like
Hmm.
so many
What
things.
kind of
Like, if-
output voltage can you make on there?
It's more about
Well, it's
processing
just
power, what you need like that.
yeah, it's all the triggering. It's got all the dip pins, so you can attach devices to it, right?
So you can trigger relays that require 12 volts.
Yeah, yeah. Well, I got the 8-channel relay.
Can't do
pad
that
right
with
here.
you can't do that with an Arduino.
No. So that's why I got this. So
I
now
mean,
I
you
can
can,
make
but you'd
some
have to make a transformer and step up your 5 volts in line.
No, it has enough power for triggering.
You know, I mean, so I'm saying on a regular relay, it requires 12 volts to trigger the relay, like a car relay. But if you have an
No,
Arduino that only puts out 5 volts, you're
no,
not
it's
going
a
to be able to
trigger.
trigger it.
It's mainly used as a triggering, right?
Right. Right. So you can trigger a bunch of transistors into.
Sure. Yeah, you can do many things with it. Yep. It's like a triggering interface, right? So yeah, so I got to learn how to program that. That's going to be a crash course of brain surgery.
Just buy Raspberry Pi for Dummies or something like that, and you'll be good.
Yeah.
The book.
Yeah.
I would have given up on the Arduino if I didn't find the code I needed. It's just a pain in the butt, you know.
Well, yeah, there's a pretty big forum on this, so I'm pretty sure I can find all the code I need to run my my triggering interface. So I can, timer circuit and delay timing. And
If you don't
duty
know, if you can't find the
cycle.
code you need, you got to start from scratch and learn how to write it.
Well, the thing is, Raspberry Pi's been around for quite a few years now, so it's got a pretty big database. So I'm pretty sure I can find one.
Well, what I found code that I was able to alter in it to do what I wanted it to do.
Sure, yeah, most of them are, it gives you the basic framework of what you want, and then you can dial in the parameters that you want, right?
I think the Arduino only does five triggers, 5 signal outputs.
Yeah.
1 negative, 5 positives.
I like it. It comes with all the dip wires, so you can just plug and play. Basically, I can hook this up to my TV because it's got an S video port. So not S video, but the other wire, what do they call it? Yeah, the S video or whatever port.
Plugging your TV into it.
Yep. Yeah,
A composite?
Yeah, it has the
Coaxial?
plug-in. No, it's got the S video. Yep, it's got the S video port on it, so I can just plug it right on my TV.
So that you can read it and work with it.
Yeah, it's basically just a miniature PC. That's all it is.
Right.
It works the same way, right? But the difference with this is you can plug into this board, right?
Yeah, get it on the screen so you can see what you're doing.
Of course, yeah. Or you can buy one of those little 3-inch screens. You can buy one of those, plug it in, and then whatever device you have it, mount that monitor into the device so you can do all your corrections or adjustments right there on your device that you just built. And those and the other thing too is you can buy a touch screen. This thing will work with a touch screen. So you can make your own touch screen interface.
Well, you said you had like 15 outputs on there.
That's relays. Yeah. So if I'm doing trigger relays,
those are 5-volt outputs.
Yeah, it's a very small trigger. It's not very big, but it can handle up to 10 amps. At specs on its load voltage.
So this
right?
is to run like industrial equipment and stuff.
Yeah, like just listen to operation voltage is 5 volts. Okay, operating current is only 480 milliamps, so it doesn't take much power to run it. And then load voltage, you can run AC 250 volts at 10 amps or DC 30 volts at 10 amps.
That's still a lot of current.
Yeah, for a little thing like this. Yeah, it's excellent. It's really,
I don't know
really
if I
good.
would want to push that much current through it, being almost $400.
Well, no, it's just this board. This board will get affected. If you blow this up, it won't affect your Raspberry Pi. So, and these boards here, they only cost like $20.
Oh,
so these things are cheap.
That's the relay board or something?
This is the relay board, HN.
So that's what handles the amperage. Okay.
This is the miniature version
that's
of
worth
the Raspberry
experimenting
Pi.
with. Then go ahead and blow.
Yeah, see, Ben's got it.
$20.
This is the tiny one, and I got the battery attachment as well. But this is a little bit more
Burn out
inexpensive
your relay, though.
if you don't need as much processing power. And it's really small,
Yeah, but
pretty cool
it's
stuff.
perfect. Yeah.
Yeah, it's got a little slot for your SD card and everything for your memory. It's all in one thing. It's really cool.
How do you call that?
I don't know exactly what it's called, but it's the mini version of the Raspberry Pi.
Yeah.
Yeah.
Yeah, they come in different sizes.
Mm-hmm.
And
you can see it has 2 micro USB, and then HDMI. I have a micro HDMI adapter here.
Well, what processor are they using?
Good question.
EEPROM, it's an EEPROM, right?
This is okay. The chip is 3IC77 D9WHB, and that's the processor. Whatever that means, I have no idea. It's a fairly decent motherboard. Like I've heard nothing but good things about Raspberry Pi.
So with your Raspberry, you should be able to flip 2 relays.
Oh, okay. Here we go. Okay, here's the processor. The processor is a quad-core Cortex A7664.
A quad-core what?
Quad-core Corex, Cortex A7664. It's a quad-core, 4-core.
Sorry, I just had to slip in an Apple coil cameo.
The raspberries are quad core. That's a pretty hardcore.
Yeah,
We're talking about
processing.
yeah, it
fruit
is.
here.
It is.
Yeah, no, it's got some pretty good processing power behind the full size Raspberry Pi. The mini one doesn't have a lot of processing power. Like if you don't require a lot,
Yeah.
it's a good
And how
choice.
much
But
is it?
I believe this
Like-
one was like $300. The starter kit, it's like 300.
$300.
Yeah.
Dude, but for that price, you can buy a NVIDIA Jensen.
Well, you're getting a small package, right? You're getting a really small package, and
yeah, size is
it's
a
got
concern
all
too.
it has all the pin connectors, so you can control other devices. This is like a triggering device for those devices.
I'll be honest, I haven't figured out what we're gonna use this Pi for, but it definitely is gonna be
I can give you an
useful for
application.
something.
I have a
Yeah,
nice
no, I'm
application.
open to. I'm open.
Mike, see if you can get your Pi to switch 2 poles on 2 sources.
Yeah, probably could.
Hmm.
This could even run on a battery. UART connectors.
You got 15 relays on there. You have more than enough to do that.
Well, I have an 8.
You only need 4 relays to switch 2 poles on 2 sources.
Yeah.
But are these relays individual bus lines?
Yes.
Oh man, that's
They're
sweet.
individual. Yeah. I knew you were going to ask that.
That is something. I might end up doing the Raspberry. I didn't know it was that capable.
I'll show you again.
Yeah, the Arduino is very limited, especially when you're working with higher voltages above 5 volts.
Well, what's great with the Raspberry is that you don't have to use transistors to switch like you do with an
This does it
Arduino.
all.
You could use
Yeah.
Does it all.
the $20
Yeah.
relay thing that goes with it. What do you call that? That part that goes with the Pi? The relay?
The relay. Hold on. What do they call it? Relay module.
Relay
8-channel
module.
relay module.
8 channels. Gee, nice. Digitally controlled.
Yep. Plugs all into your. It comes with the wires and everything to plug right into the Pi.
Well, hey, there you go. There you have you're able to switch.
Yep.
With that, you can switch my circuit easily
You can do anything with this.
without having to go through a whole mess of transistor
Bullshit.
wiring and all that.
Yeah.
No soldering either, because it's
Yep.
right. It's
No
a relay.
soldering. Yeah, it's plug and play. It's all plug and play.
That's handy.
Yes, it is.
When you got to do
Mike-
experiments by desoldering and resoldering and
Are you talking about using the Pi as a replacement for the Bedini circuit? Because that would actually be useful.
yeah,
for,
no, you can. Yes, you can. You can
reducing
use
the
it to act
size
like
for
a
the circuit.
transistor. Uh-huh.
Yeah,
you
because
could
right
use
now
it.
okay,
No, any switch
that would reduce it quite a
the
bit.
transistor is just a switch. It's a relay is a switch. A transistor is a switch. They do the same thing. They just have different ratings on what they can handle, what the switch can handle, speed wise and amps and all that.
I'm just gonna scoot up for a quick cigarette. I'll be right back. All right.
But with the Bedini thing or anything that's flying back, you want to use not a transistor, or a microcircuitry device like a transistor, because that flyback is always going to get to that transistor, because it's just the nature of these microcircuitries. They're real sensitive to high voltage. But a relay, it's not going to get damaged by flyback, and you're going to be able to keep your system running the way it's ran when you first started it. As where with a transistor, it'll run really good at first, and then the flyback is hitting it here and there, and it starts running less good over time, and you're like, what's going on? You think everything's fine because everything's running, but it's not running as good as it was when you first started it. Well, that's because the transistor got slightly damaged, but it still switches, but it's slightly damaged.
I noticed that happened on one of the channels of my stereo amp. It didn't fully just die. It just got reduced and then it died.
That's what the flyback does, stuff like that. If it don't totally burn it out, it slightly damages it. And I've noticed if your transistor gets slightly damaged by the flyback, it seems to never burn out. It just keeps running slightly damaged. It's weird.
Yeah.
Whereas other transistors will just stop running altogether, or they'll stay closed or stay opened or whatever. But a relay is not susceptible to that because it's a spring controlled relay, or it's controlled by a small magnetic field that moves a piece of metal, and you can't really damage that with flyback.
Interesting. I didn't know that.
It's not a microcircuitry; it's a relay.
Yeah.
You guys want to have a little fun?
Oh yeah.
Absolutely.
Oh, okay. Check it out. I got the back off of this thing.
Oh. Oh,
We'll light
Is that
this
an
thing
old
up.
tube TV?
Yeah, time to get a little high voltage going.
I'm peeking under the skirt here.
And that coil on the back is the flyback coil that captures the reverse polarity signal of the coil that's running the TV when you turn off the TV. It does that. And if that coil's not there, it would blow up the TV, which has happened in the past.
Come on now.
But the TV has to be running for a long time. Usually.
Oh, I hear something.
Please tell me you got that thing unplugged from the wall.
Oh.
Yeah, baby.
Woo!
Oh, find it out. Hell no, I don't have it unplugged.
Oh wow.
Oh, yeah, it's going to be a good one.
Ooh, that was good art.
Is that a magnet?
Oh,
I
man.
don't know what that is. Honestly, I don't know what he's doing, but
It's
it's
just
cool.
the flyback, man. That's how you do it. Hold on, let me turn out the lights. Let me see if I can't get this thing going.
Mike is missing this.
Have you ever tried hitting a magnet with that spark? You get any reactions from a magnet?
Nathan, what is that thing you're holding with the fly?
Oh, shut off.
The transistor blew.
Sorry, it popped it.
It's dead.
The ultimate way is to have your circuit set up where you can just plug the transistor
There we
in,
go.
and when it burns out, you can unplug it and plug another one in.
Are you on?
Yeah. That's why I like the breadboard. I can just unplug it.
But even the breadboards, those terminals, they don't last very long. They have these
Shut off again.
something else that does the same thing. It's
That doesn't want to stay on right now. It just keeps popping off.
What is the thing you're holding towards it? What is that wire? Is it what is that?
that's the end of
I
the
don't
coil
think he
that's
has his
generating the
headphones
high
on right now.
voltage.
He might have took his headphones off. Maybe it's a
Low
magnet. He
current.
said it's a flyback. I'm not sure. It looks like a little magnet, maybe. He's creating some kind of spark gap.
Sorry.
Phil's on Pluto.
What
Hey,
was holding towards it in the clamps? What was that thing? Is that the end of the wire or is it?
Oh, so your TV has this thing that goes in the top right here, right?
Mm-hmm.
Right here. This is your high voltage line right here. Okay, it comes off the top of your flyback.
Oh, okay.
So this wire right here is the grounding wire for your TV.
Okay.
So I'm
Oh,
just
okay.
short circuiting it right there from the hot to the ground,
Okay.
and it makes all the spark. So when you set up your spark out, that's all you have to do. Now the cool thing is when you have a remote, you just push the button and turn it on and off whenever the heck you want to, and you can start getting voltage that way. The only thing is that it heats up the circuits underneath. That's why they shut off like that. So it's better to pull out the flyback and use it that way. But that one's a good one. So you could tell by the amount of plasma spray you get. So at 1.5 inches, if I start to get a nice hissing sound, that shh, that's exactly what you want. As you pull it towards it a little more, it'll start to spark, and then you pull it away, it'll start to go because of the capacitor size in there, and then you'll get a nice long arc. And I want to say they're about 4 inches long at the at the longest right there. So that's a good flyback. That's going to work out really well for what I'm doing. So
Nice.
That's awesome.
yeah. Well, what are you going to do when you got stuff in your garage like that? Don't ever leave something like that in my house. You ain't getting it back.
We enjoyed the fireworks, that's for sure. There's some cool arcs.
No,
Yeah.
no, myself, I get all this equipment. I did all my tests, but I kind of lacking. I want to move on to the next step, but I need imagination, man. I need
Let's talk
your
some physics.
advices.
Phil, let's talk.
You need
some
magic
physics.
mushrooms,
I'm not a
Phil.
physicist, but I could definitely debate this stuff, okay? Because I have some physics. I'm a physical being, and I understand physics for that very reason. So I understand you're trying to get these calculations going to get your gravity, the amount of gravity field generated, right?
Well, he's working on the amp side, so it's a little harder because he's got a lot of heat. So it's only goes like a minute before it has to cool down because the massive amount of heat there, right?
Right, but
Talking
he's
about
got
the
he's
liquid
got
metal
calculations
vortex?
going on to figure out the amount of gravity generating from the device, correct?
You're talking about the liquid metal vortex?
Yeah,
Yeah,
the MHD.
yeah.
You're trying to calculate exactly how much the
Yeah,
gravity.
but it's very simple because I figured something else this week. The gravitomagnetic energy that it generates is exactly the same thing as the kinetic energy. So the kinetic energy is the energy you
Kinetic
gain when
energy
you
is
move.
momentum or whatever.
So the energy you gain when you move is exactly the same as the gravitomagnetic energy. So I link the two together and I get the same equations. And it's really simple to understand and it makes sense. You have an object that moves, it gains energy, and it's gonna emit more energy. And that's exactly the same thing as kinetic energy.
An object, well, if it's moving, let's say an object like, here we go. We have a stone that has 10 pounds of matter,
Yeah.
of weight, of earth weight, and something else throws it and gives it energy. Its original energy is still the 10 pounds of matter. And
Yeah,
that's its origin energy. But the energy that was given to it to get it to be thrown came from somewhere else.
Yeah, but you're working on the laws of the Earth when you shouldn't be. When you do with the anti-gravity.
I'm just using Earth as a reference.
Well, I understand that, but I'm going
It
to
could be
say
another
this.
planet. The gravity of that planet, it doesn't matter. The fact is, something on that planet picked the rock up and threw
Well,
it.
it
And gave it
does.
that motion.
It does matter.
And
So,
it doesn't change the energy of the rock
okay.
itself. It
Let me
changes
just tell
the
you.
combined energy of the rock and its
Fuck, man. Let me
motion.
just tell you what it is. Okay, it's the dielectric. You're trying to increase the dielectric. You're trying to take something that is non-magnetic and making it have a magnetic signature to it. You're trying to increase. How do I want to say this? You're trying to overload it.
You can look at it
You're
like
trying
that,
to
yeah.
saturate it. When you reach the point of saturation, you get force. You're trying to amplify that force. We're not talking
If
that
it's the dielectric,
you
here's
don't-
another argument.
Stop.
If it's the
you
dielectric,
don't want grams of force. You can get pounds of force easier with high electricity versus high current. Okay, it just works that way. That's why the power lines can move together. They're always attracted to each other because the dielectric's so high. It has nothing to do with the amount of amps in it because there's very little. It has to do with the amount of volts in it. And once you can get that object in the center, now you can multiply it. Now you'll start to understand T.T. Brown's capacitor because he's taking it such a high dielectric in order to get it. He's putting like a bunch of pounds on that thing. We're talking like he can equal the weight of the whole craft and more. That's what he's doing. Okay.
The dielectric is also dependent on the material and what it can be charged up to.
Yeah, but the whole thing is, look, I don't care what material you use. Okay. Some of it's an absorption material you don't want. In steel, it's real simple. You put the two far apart. Okay. You make sure one's bigger than the other, has more mass, unless you want the center to be completely overwhelmed. You have to put a size difference between the two. You'll get a heavy dielectric and you'll get pounds of force. You'll be able to push way past what you think you can with grams. Trust me when I say that. The effect is so much better because now when you take the amount that's in the center that's not supposed to be magnetic, it's not supposed to be charged like paper, then you can amplify that amount of paper by putting more levels on it. Keep the same diameter, but your thickness is going to be less. So you can take and stack more on there. That's going to amplify the amount that goes into it. So your dielectric is going to be so much higher. Then you're going to be able to pull out way more force. That's how it works. That's how it always works in the lab test. Okay. That's how you can get pounds of force on your scale instead of grams because you're using exactly what they told you was there. Okay. You can listen to every single one of them when they talk about high voltage lines. It's exactly what they're telling you. They're telling you that dielectric energy right there, when the piece in the center reaches saturation, then you're going to get such a heavy pull force in one direction because one size is bigger than the other. Now, if they're equal, the saturation stays in the center. The part is one's bigger than the other, so it always goes towards that field. There's only one case that it does not. And that's the case when you can actually take a lifter, push it up in the air with weight on it. Okay? And that's a very special state to find. Once you find it, you have anti-gravity. I've seen it done.
Well, he's
Sorry.
trying to calculate for the gravity field.
Yeah, but you have to use the right equations in the right area to get it. Not everything calculated in what you think it is. That's what I'm trying to tell you. There's a whole different math here when you get to the correct things to calculate. So, sorry if I was being rude.
But Phil, you're using a particular math from someone, right, to get this formula?
Yeah. So
Well, I'm using the math of some professor that was calculating the magnetic field generated by a charged disk spinning charged disk. But I just changed the charge disk by a mass, and then it generates a gravitomagnetic field. So I just changed two variables, but the formulas are the same. And yeah, I've got all the maths. It's calculus I copied from some professor.
Right.
So I know I'm right. I know it's correct. And
So you said you found out that two variables are actually the same thing.
yeah, so you have a charged disk that emits a magnetic field. It's the same thing as a massive disk that emits a gravitomagnetic field. So all you have to care about is the gravitomagnetic permeability. You just change
Of what? Of what? The area that the field is in? Because that changes everywhere you go, doesn't it? Or is it all the same?
It's relative actually. It's a relative variable, so it changes. It's not absolute.
Right. I wouldn't think it would be because there's different bodies of matter out there of different
Yeah, exactly.
And
But
that's
on the
why-
densities.
we're talking
that's
on the
why-
surface of the Earth.
And that's why the speed of light is an arbitrary constant. That's what
I
Dollar
don't
taught
even
me.
like to draw in the speed of light. Everybody likes to. I don't even like doing that. I
Well,
think that
this
just
is
confuses everything.
where
Because
this
light's
is
not
where
even
the
moving, in my
Einstein
opinion. It's not
physics goes
speeding
down the
anywhere. It's
toilet.
not moving.
So Phil, you
It's
changed
emitting.
from the rotating disc to the rotating liquid metal, right? Like this is
Yeah.
what you
So
changed.
the only difference with the rotating disc and the rotating liquid metal is the rotating disc uses an angular velocity, and the rotating liquid metal uses a tangential velocity, because it's going to be like a
Can you
spiral.
describe a little bit the two velocities, the
Or ta-
tangential and the angular? Can you help the audience understand what that is, including
Yeah.
myself?
So you have a solid disk that is spinning. You're gonna use the angular velocity, or the RPM, or whatever you want to call it.
If you
So
give it an angle, that is. What if it's horizontal completely? There is no angle now, other than the
yeah,
180.
so you have a flat disk, and the angle is the amount of the angle the
The
angle
amount
that
of
you had
the
every
amount of
step.
off horizontal. You mean the amount of angle you are off horizontal is what you're saying.
Yeah,
That
exactly.
is your angular velocity.
if
Yeah,
it's
And what
flat,
is the tangential? The
the energy
tangential part,
go that way.
tangential. Yeah, you
right?
got
So
it,
you, Lulu, what he's
Lulu.
saying is your angular velocity is anything off of horizontal 180. This is 180 horizontal.
Okay.
Anything off of that, you calculate that, and that's like 20 degrees.
Yeah,
And then
exactly. Yeah.
more that way, and like
That's
the
your angular
So
velocity.
when you have something solid, you use the angular velocity, or the RPM. And when you have something liquid, you use the tangential velocity, because it's going to be like a spiral. If you have water or liquid metal, you're going to use the tangential velocity,
So meaning
because
it's
it's
not one spin. Then it's more.
because depending on the radius, the speed, the angular velocity is going to be different, but the tangential velocity is going to be the same. So it's going to create like a spiral.
Oh, so the tangential is always horizontal. It never shifts.
The tangential is
The vertical.
yeah, you have a circle. Sorry, you have a circle. The tangential velocity
The
is the
vertical.
straight line. The straight line, the infinitesimal straight line that represent the speed of a infinitesimal angle. You know what I mean? So you have a circle, and the angle if you take an angle very small, then you're gonna be able to have a tangential speed that is in a straight line.
Oh, a slight curve. You're saying.
Yeah,
Well, liquid
like
vortexes, so it'd be a curve.
Oh, the tangential curve. Right. It's a very subtle curve. Right. It's
yeah,
it's never completely horizontal, or it's a slight curve. It's like
it's
liquid.
like a
Right.
spiral.
It's a
That's what it is.
very small angle on it. Is what you're saying. Is the tangential. And it doesn't,
Tangential velocity
and
is
it's non-variable. Is that what it is? It's non-variable. It
it,
just
well, it's just it's the same. It's the same, but
stays
uh,
within the same range all the time within
it's the
that
same
very
for
small.
different radius.
Uh-huh.
It's the same for different radius, but the angular velocity is not going to be the same for different radius.
like if we
So
can
So if
yeah,
you,
or mass vertically
yeah,
or more surface mass.
yeah. So all that matters is
well,
when
what
you
he's
use
saying,
the
what he just said there, by the angular velocity of a larger radius would be a lot greater.
no the tangential
Yeah, it would be because you got
velocity.
a larger radius, and the same angular
No,
velocity would have a lot more impact.
no, the angular velocity of a large radius is the same independent of the radius.
You're saying that a larger radius with a the same angular velocity is going to be the same value. It's not the amplitude of that velocity is not going to increase with a larger radius disk.
Yeah, it's going to be the same, but
Huh.
the tangential velocity is going to be
It's
different for different
increased.
radius.
The tangential increases.
Yeah, exactly.
So the vertical slight
The
angular
yeah
vertical line.
the straight line of the infinitesimal angle.
Yeah, that's the vortex part, the center, right?
Yeah,
The
yeah,
tangential. Or
yeah,
sorry,
exactly.
yeah, that's nuts, man.
So, but think about it. It's the same. Everybody is afraid every time I talk about the gravitomagnetic force, but it's the same thing as the kinetic force. It's the same. It's the same thing.
Yeah,
Something
it
that
is.
moves creates energy.
Well, if it's got mass and it's moving, and you just because you can't see the mass moving doesn't mean it's not moving. Because mass is not matter. Like gases out there, they're just not matter, but they're gases, so they have mass or whatever. But they're moving. Well, you may not see them moving. They look like just like a cloud of gas sitting there, but they could be moving, and therefore having the reason why they're creating the forces they create with the galaxy is, the
Yeah,
gases is what creates these galaxies. They must be moving. They
yeah.
don't look like they're moving, but they are.
So yeah, but I think Nathan understood what I meant, and but you got it, Mike.
So you said a
So
larger diameter angular velocity has the same angular velocity no matter the diameter of the
Yeah, no
disk,
matter the radius.
and the only change in amplitude in velocity between the two, tangential and angular, is the one tangential going out the center with the slight less than 1 degree curve on it, which is the center of the vortex. I'm assuming, right?
Yeah, so if you take a solid disk, it's either you take a solid disk or liquid that is spinning, makes the whole difference. Because if you have a solid disk, the angular velocity is going to be the same. The tangential velocity is going to be different.
That's
But
strange. You would think that the angular velocity would increase with the diameter.
if it's a solid disk, yes,
Solid.
yeah. But if it's a liquid disk, like the liquid metal
It
vortex,
doesn't. Oh, that's
it's
weird.
the opposite.
Huh.
It's gonna be you're gonna flip the opposite. One is gonna be the
It
same.
decreases.
Yeah. So the angular velocity is gonna change, but the tangential velocity is gonna be the same. So it's the
On the
opposite
liquid. On the liquid's going to
on the
stay the same.
liquid. Yeah.
Ah, wow, that's crazy.
Yeah. So the liquid is the
What do
opposite
you
of
make of
the
all that?
solid.
I mean, what does that tell you? I don't know what it tells me yet. I'm just going to keep that in the back of my head. But
Was
what does it?
it's
What does it tell
just to
you?
do the maths and to have because I need to reverse engineer the gravitomagnetic permeability, so I need to go through all the maths.
Why one field? One of the fields doesn't change when it's solid, inverts when it's liquid, and the other field also does the same inversion between the two states of matter. Well, that kind of tells you that the liquid. You're saying the liquid doesn't change the tangential doesn't change with liquid. It only changes with the solid. Is that correct?
Well, you have the
The
angular velocity, the
tangential
tangential velocity. So
increases
one is
with solid
constant.
only, right?
Yeah, exactly.
And liquid it decreases.
Yeah, exactly. No, it's either one is constant, the other is variable,
Right,
and
right,
then
right.
it's
I
the
got
opposite
that
for the
part. Right.
solid and liquid.
I got that part.
Yeah,
That's right. And the other is constant. The one that changes, right? That's peace.
yeah.
So
So, so
so
yeah,
maybe solid matter spinning matter is going to be the one for vertical lift, no? Not spinning liquid, because the tangential force increases with the solid matter, not the solid liquid.
But the force is perpendicular to the spinning of the disc. That's the thing.
It's inverted.
It's perpendicular.
I can't remember offhand what that meant exactly, perpendicular.
So perpendicular means um,
Parallel?
no,
Yeah, so perpendicular is the opposite of parallel. It means crossed.
yeah, it
Across.
means like
Where
that.
parallel never crosses.
You have a plane, and perpendicular means
Yeah.
But
it's crossing.
90-degree angles, I believe. Yeah.
So then they kind of cancel. You can't make anything out of it, right? Because of that. You get it kind
Yeah,
of like.
well, that's the anti-gravity force. Anti-gravity is just a gravity is just a energy potential. That's all it is. It's a difference in energy. Call it gravity, magnetic, and electric. It all generates a force or an acceleration.
Okay, I have a question. Imagine this in a sphere, like two spheres, one sphere and then another smaller one, but the liquid is between them into a vortex. Would
Yeah.
wouldn't that somehow create a magnetic field that could levitate? You know,
No, you need to have a disk, not a sphere,
okay.
to create a perpendicular force.
Okay. So it's gotta
But
be
yeah, if you have a sphere, it's gonna cancel out. It's gonna create a force, and from the bottom, but the top is gonna cancel the bottom.
mm.
He's gonna do the opposite. So that's why you need a disc. And
You're
the
talking about a
TR,
3-plate setup, like the thing on the top, one plate, and then another one.
yeah. So it's all vectors, so you can stack them up and add them up together. And but that's what the TR3B is. That's a vortex of plasma or something like that. But it's almost the same thing. It
Yeah, right
creates an
before
energy.
the plasma state. You want it right before the plasma state.
Sorry.
You want it right before the plasma state, and you want to
Yeah,
saturate the center plate, and then you
yeah,
have to pulse it.
yeah. But plasma is just a more energetic vortex. Um, but I can't do a plasma vortex here at home. But
But it's
that's
also
what it
using
is.
the energy. It's using the energy instead of applying force.
Yeah. But it uses, I'm pretty sure it uses the MHD as well, and to make the plasma spin. But you need pretty much massive plasma. You need the plasma pretty massive.
Yeah,
Uh,
you need the dielectric to be massive. You need the plasma to be almost non-existent because you're burning off the dielectric every time you get plasma. So you're not getting a charged state out of it. You're going to get far less. Every time plasma gets, it uses the energy. You need to use the energy as force, and it won't let you do it as soon as it burns. It's it's
yeah,
it's like light. As soon as you see the light, you know that you put amps in it and you're slowing it down. When you don't see the light, it goes much faster.
yeah.
Sorry, I was just soldering. I got, you guys know I have ADHD. Just making these connections for our breadboard. Very simple. Speaker wire terminal. Solder some Arduino jumpers on there real quick.
I mean, I don't know. I mean, light doesn't travel; it emits. It emits. And that's like not the same thing as running with legs from one point to the other. It's not. It's an emission.
Yeah. So when you start moving, you gain energy, and when you gain energy, you're gonna emit energy as well.
Yeah, I agree.
Right. Emissions can, get you from one place to the other, but light is that one photon did not, go from point A to point B. It emitted itself over and over again from point A to connect in a chain of something, chained it over there as a past emission.
The same photon is
Not the
never.
same emission, a past emission.
It's never the same one that you end up with. It's just a constant
Or
transaction.
radiation, it's an emission
And
of radiation.
yeah, like one photon is not the same one that gets expelled, like the emission out of it, where
What I'm saying is the photon that it left the source, it didn't go anywhere. It emitted itself somewhere using emissions, radiations and emissions. It created its signature somewhere else.
Without movement.
Right. Instead with radiation, vibration.
The resonance, yes.
And yes, of course, particles can travel on that wave, just like a surfboard or whatever, or coconut in the ocean. But the wave itself is not the particle. And why are people calling light a particle? I don't get it. Or scientists or
Yeah, I think you got two different theories crossing right there.
And when they call light a particle, to my mind, they're saying that the light is the coconut in the ocean. It's not the wave itself, which in my mind, it's the wave, not the coconut.
Drowning Penguin on my channel just said Old Man Builds has an excellent conceptual understanding. And thank you for the subscriber to Nicholas. Appreciate it, Nicholas.
What they call light light particle,
By the way, some guy on the chat asked me if I needed an up converter. I'm good because I already have a low frequency receiver. So I'm just answering a question from V Sears, I think. Sorry to interrupt.
The best explanation I heard of light coming from the scientific community lately is that it's the magnetic field bending in on itself, curving in on itself. That's where the light gets emitted, where the magnetic field curves in on itself, right at that point.
Yeah, but light's emitted and it travels, right?
Yeah, because it's a particle and it's that coconut riding on that wave in the ocean.
That's all I'm asking.
Why light is the wave? It's not the wood chips carried on the water waves. It's the water wave itself. It's not even the water. It's the wave that caused the water to move or to shape itself like that. That is the energy that got the water to shape itself like that into a wave. But it's not the water. The wave is not the water. The water's the water. The wave shaped the water. We all know that's not that's not wrong. That's correct. The water is the water. The wave that got emitted into the water then shaped the water into that geometry. So the same thing goes with light. It's a wave. It's a frequency wave up in the high bands. It's not a particle. And they want to call it a particle wave for some reason. I'm not a scientist to that degree to understand why they call it a particle wave, but they're calling these things particle waves. I mean, how you can even call a wave a particle, any kind of wave, I don't know. Because all waves have no matter. They're just energy.
But it's because it has structure. That's why.
The geometry, right?
The light has structure. That's why they call it that.
Maybe. I don't know. I haven't figured it out yet. But when I hear particle, I think of matter, and I don't think of mass. I think it's matter.
Doesn't matter how much mass it has. It just has structure.
Yeah, but light has mass. It's not matter. It has no matter. Light is mass. It's energy mass. It's not matter yet. It might become a matter and then a particle.
Okay.
I don't
But
know.
matter is just the result of the virtual particles. I mean, it's just this it's not like a ball of pool, you know. People see particles like balls of pools that 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 hit each other, and you know, like then that's not at all what it is. Particle is just the results of the virtual particle cohesion, but it's not like a ball of pool. You know what I mean?
So when they say particle, they're not referring to like matter.
Yeah, particle is just a virtual particle that emits a force, and you have a distance and stuff like that. But it's not like a ball of pool that's gonna hit like other balls and and bounce off
A
the
particle,
border and things like
a
that.
particle of force, because they don't know what else to call it. It has no
Yeah,
matter to it. They got to call it something. I guess.
but
Well-
that's the error.
I guess
that
it's a matter of fact.
A
Yeah,
matter of fact.
that's the error that they all claim. Oh, we don't understand why an electron can survive. Can be subject to the split experiment.
I mean,
to
you
the
can clap
double
your
split.
hands and create a sound wave, and it's a force.
Yeah, it's just a the side. It's just like the side effect of the force of a virtual particle. That's all it is. Virtual particle. We cannot see them. We cannot test them. But it's just a force emitted from a virtual particle, and but it's not like a ball of pool. It's just a virtual particle that emits
I
a.
guess when you call it a virtual particle, it makes a little more sense because it's just saying a virtual particle is like saying, okay, the dude over there clapped his hands, the sound wave came over to here, and that's the virtual particle of his hands creating a virtual sound effect over there.
Yeah, I don't think it works that way though.
Well, no, you go from reality, which is the real hands, creating a virtual effect somewhere else from that real matter. You know,
you're just creating a wave, and the energy burn off is your light. That's it. It's the amount of energy used out of the wave that you put into it. That's what it is. Because the wave from the sun still gets to the earth, but we don't see the light all the time. We don't see all the burn off. We get the wave, and the wave interacts with the field around the earth, and when it presses upon it, you get the light. So it's the amount of burn off. That's it. Because we don't feel the wave on the ground, we feel the light. So it's energy being used. It shows up in every high voltage experiment you do. And when you can pull that further apart, you'll just find out there's an energy wave there. And as a matter of fact, I don't even know that it's a wave. It's more like a scalar field than it is a wave. So, yeah, it's just burn off.
I thought a scalar field was just a very low frequency, large wave. ELF or something.
It's a point-to-point wave. It's more like resonance starting resonance in another Tesla coil. It's simply turning it on by frequency, and that frequency turns on the other one. But it has to be a resonant frequency, not just a frequency. If it was, radio would set off the world.
So you're
The
saying
thing
quartz
is-
crystals are scalar waves? Like, quartz throughout the earth has a lot of, reception with all the quartz. They all
Quartz
wave.
crystals.
So that would be considered a scalar wave because it bounce and keep going. Kind of like our radio antennas are tuned. They're now scalar waves.
Well, it depends. If you can turn on a quartz crystal and have another one turn on in the room, then yeah, it's a scalar wave. But until I see that, I can't exactly tell you
Right.
that's true.
So two antennas finely tuned with each other is considered a scalar wave.
Yeah, it's an energy that you can't see that's just there and it emits. Now, the two antennas, maybe not. It's a little bit different in that aspect, but two two coils with the exact same resonance frequency, yes. Not frequency, resonance frequency. They have to be resonant to each other in order for one to turn on the other in the room without, being that close to each other. You can have them like 10 feet apart and they'll still turn on. They have to be the same resonant frequency. So.
The Tesla coil.
Yeah, they're a little bit more than just sparklers. There's a third kind of energy Tesla came up with, and it's a cold energy. And he said it made his whole body go purple. And I've seen the field. It comes off the wire purple just like that. And it'll light up. Now, as soon as I can get enough of it, we'll see if it goes through my whole body and I'll do it. So, but does it go through the wire and do it? Absolutely it does. Without a problem. And it's cold and it's safe to touch. So,
Yep.
energy's different. You just got to know what it is.
Would you return back to your normal color, or like?
God, I hope so. Imagine turning off the lights at that every night. You'd be glowing.
What is that? You'll turn into Barney?
Yeah. Old man Bill turned into Barney. That's hilarious.
Fidget toy, but it's not a fidget toy. It's like a
Nice.
I don't know what you could call this, but it reminded me of a wave, or zeros and ones, you know?
Nice.
Yeah, I mean, this is probably, it's a configuration of what a wave could be, all the different places it could, I don't know. I thought it was a cool thing.
So talking about waves, I'm gonna present I'm amazed nobody thought about this in 100 years. But to teleport energy, all you have to do, I think I said that before, but all you have to do is convert high frequency photons into low frequency photons of high density and back and forth. But it's very simple, and then you can teleport energy. So,
What's the distance?
well, the distance, if you convert the high frequency waves of low density into low frequency waves of high density, then you can travel through matter more easily. So you can go anywhere you want. You're not gonna get blocked by walls or water. So
Okay.
that's the way to teleport energy.
Are we talking like feet, or are we talking about miles, or are we talking,
It was the lower the frequency is the farther away you're going to be able to teleport the energy. So
if Phil sends us energy from Canada, let's say to Houston or to Florida or to yeah, I mean that'll be something.
No, but you guys understand what I meant. Nathan, you got it.
Long range frequencies versus short waves.
High and low density back and forth. So it's very simple, and I'm surprised nobody thought about this in 100 years. But I'm gonna talk about that because we could teleport energy from the sun, teleport it anywhere on the world. It's pretty cool, It's like we can't. We're not gonna complain anymore that it's cold or blah blah blah. So
it reminds me of the radio they came up with that they said was like teleporting. That you could stand in London and stand in the U.S. and you'd be at both places simultaneously. So, yeah, I forget the name, Thompson or something like that radio, and it had to do with the rotating field that he created in it. So it's probably not the same thing you're talking about, but it just reminded me of it.
Oh yeah.
Was it riding on the magnetic field?
From what I understand, it was riding through the ground, and the energy goes right into there.
Oh, okay.
So I could be mistaken on that, but I just remember Alexander Radio. There you go.
Because with the magnetic field, like the Earth gets bombarded with a lot of solar flares. So every time like it gets hit, it creates a magnetic flux around it, but it touches at 2 points and then releases.
That's
So
because the Earth has a lot of iron.
So if the signal's riding on that, yeah, that would be correct. That it's existing in 2 places on Earth, because it does 2 places and then it releases. That would.
The sun, when it ejects that energy, it hits the iron core of the Earth, and all that flux is created. The energy from the sun hits the iron core, just like an electromagnet. The wire sends energy to the iron core, and the core generates flux. Iron is very magnetic. I don't know if it's the most magnetic metal in the planet in the cosmos, but on the planet, I think it is.
It break the solar flares break the magnetic field, and that's
right, and then they hit the core of the Earth and generate more fields through the iron core that the Earth then shoots out again.
Yeah, I don't know that the core of the Earth is actually the ball of metal they keep saying it is.
Well, if it is, it would be. If it is, it would do that.
More like a resonance chamber.
Yeah.
Well, you figure they built that model of Saturn.
Even if it's a resonance chamber,
it gave them everything it was.
It would still absorb if it was a resonant chamber, it would still absorb the field from the sun, and then eject it out some other different way. But eventually, it'll capture and release, just like any material would capture energy and release it later, as it does in its natural material state. Iron is really good at capturing energy. It seems like energy. I don't know. Creates a really strong magnetic field when you charge it with a coil. Iron. You could do that with copper and get very weak magnetic field. Do that with aluminum and get it.
Well, I don't doubt that there's a heavy magnetic field around it, causing the rotation that goes on from both the top and bottom of it.
There's definitely a lot of iron in the core somehow, either in crystal form or whatever. Iron.
It doesn't always have to be iron. It could be bismuth, which is basically just magma, and that could be just the flow of magma doing it. The heat around it could be creating it, and because of that, it gets rotation.
I heard bismuth, it inverts whatever magnetic field it sees. That's what I read about bismuth.
I wasn't talking about bismuth. Basalt.
Oh, basalt. That's a rock. Yeah.
Well, yeah, but it's also magma when it's in,
Right. It has iron. Right? It has a lot of iron.
Yeah, and it's got a lot of magnetic field around it. Natural magnetic field, not the kind we induce.
Well, we also have iron.
No, I get it.
And it's very important for our biology. Without it, the hemoglobin can't get oxygen.
Yeah, well, resonance chamber puts off an awful lot of heat. I mean, a massive amount of heat. So you're going to get magma everywhere.
So I got to get going soon, but I had an interesting update before I leave.
Yeah, we're going to be signing off soon, very soon here. Yeah, any last words?
Well, I soldered that terminal connection to provide a more solid connection between the speaker wire and the breadboard for the reference circuit. I had a suspicion that's why the mini board was not working correctly. for the reference circuit, and that I was correct. So the system is working flawlessly now. You see the reference circuit shine brighter when it's not in resonance at like 60 hertz, and then opposite happening for the output when it's in resonance. But an interesting thing I noticed at 60 hertz, instead of the lights blinking, they were solid. So that denotes to me that there's some kind of smoothing application happening where it's smoothing out the signal, like, and if some amps do that automatically, maybe the mini board has something built in. And that might be why we're not getting the perfect signal that we got on the Technics in the stereo, the Insignia stereo. So I thought that was relevant.
Excellent.
So
Well, guys,
continue.
I think we're gonna square it up for the night. It is getting late. I'm sure everybody's getting a little tired. Yeah, our live chat tonight was awesome. We had a really good live chat going tonight. A lot of questions.
Oh, just one sec. We're not done. We're not done yet. I want to talk about something.
No, go for it.
Yeah, right here. The Dyson Sphere. Have you heard about that?
Yeah, the Dyson Sphere is supposed to be able to use or harness the ability of the sun, or the energy of the sun.
Yeah, definitely. So, can you imagine if you collect the energy of a star and you teleport the whole energy to anywhere you want, like on your planet or something like that? That would be extremely efficient. So I think that makes sense that the Dyson Sphere really exists.
Maybe there's one inside the Earth.
That would make sense.
Yeah, but a star would be more effective.
We would become a civilization type 2 or 3. Right now we're not classified as we don't have a number.
Where do they get all the metal for the sphere?
I don't know if it's metal. I think it's some other material, right?
Yeah, I have no idea.
That's a lot of mass.
Yeah. Maybe it's a chicken and egg thing,
Honestly, I think this Dyson Sphere is just a big distraction. You cannot close off the energy output of a radiating star. You have to let it radiate.
I mean, that'd be the size of a planet. You would need to make that around that. And if you took in the whole solar system, my God, how many solar systems are you killing to do it?
Maybe the Dyson Sphere is not exactly closing off the radiation. It's just graphing it and letting it radiate somewhat and capturing the rest.
It doesn't have to be full coverage. It could be like a mesh, like a net kind of.
Well, it is a graph of some kind, right?
Even that's a lot.
Remember, we've got a lot of asteroids out there.
Well, the theory about the Dyson Sphere, from what I remember, is that you're going to use like AI robots to build it. Robots that replicate themselves to make the sphere faster, and they just go under rocks and harness materials to replicate themselves to then go
Terminator asteroid robots. Is that what we got?
No. The concept of making the Dyson Sphere was to first develop a AI robot that can then replicate itself. Little miniature builders.
No, I get what you're saying.
They can launch out there to land on rocks to get the materials that they need to replicate themselves, to then use the materials from the rocks to build the sphere.
Search the
batteries not included
on automation kind of thing.
Search the Kardashev scale. I'll tell you.
Good luck with that. I mean, as a technician, I can tell you that. Good luck with that.
They're going to be the asteroid trash men. They're just going to keep taking.
Go build your Dyson
reusing
Sphere
the trash out of the asteroid
with AI robots.
Dyson Sphere.
Huh. Like if you use the Kardashev scale, it'll tell you exactly, what type of civilization and in how many years we would probably achieve that.
Oh, I think that thing's broken.
You're talking.
They're putting goals on there that are not realistic in science.
You're talking the efforts of multiple civilizations.
Talking about
thousands of years of our timeline.
They haven't figured out how resonance works. Are you sure that they can
we
even?
Can't
get
even
there?
last.
We get great wireless energy just by resonance, and they can't even figure out how to do anything else. There's no way that they got the math correct to do that.
I mean,
They don't know what type
You
of
would have to
civilization
have
it
a
is.
robot do it. You'd have
If-
to have a
Man,
machine
that's
do it.
that's just smoke out of their butt.
if you think about it, we already have the International Space Station in orbit. Why don't they just start building off of that? Because it's already in orbit, it's already rotating, it's already, locked in that orbital, that.
Because all the technology that's significant for actual space exploration and civilization is all black budget. It's all kept from the public. They just want us to live in this facade where the International Space Station is the best we can do, and there's nothing we can do about it.
Oh,
I mean,
that's a
I totally
total
would rather
lie.
spend our
No, I know.
call it a
But
black.
it's sad. We
I don't know.
lost the technology to go back to the moon. Oh,
Yeah, how
Yeah,
can you
right.
do that? Like, how do you do that? That doesn't make any sense whatsoever.
That's a lie.
no, the public's not buying it anymore. They're not
No.
buying it.
Do you think the public would approve space programs or wars? Which one would actually say, okay, this is what the public money we want it to be spent on?
They want wars because wars is gonna increase our deficit, and on both side of the war is gonna increase our deficit, and that's what the banks want.
So
They
is
want us to pay interest off of their deficit.
but so is asteroid mining. I mean, those things are like have precious metals in them. We could bring them back to Earth.
Yeah,
and
hold on, but rich people want to thin out the population, so their way of doing it is starting wars and killing regular folks like us. That's
They
what they
still
do.
need labor power.
They want
though, so-
population control, and that's the way
Yeah.
they do it.
Yeah,
It's
that's
really
true.
not about money, or it's not about anything. It's just population.
Yeah. So
Yeah, that's what it is.
Innovation is against their agenda, so they're doing everything they can to slow us down. Because innovation breaks the vicious circle of us being in debt all the time and paying credit cards and
Yeah.
and
Hey, hold
deficit
on.
and-
You don't hear nobody complaining about population control up in Siberia, do you?
Who cares about Siberia? They get a hold of all the nations that are big, and then they kill people.
Put this whole population control thing in the garbage with that
Yeah.
statement I just made.
No, they
Let's all sit around in our igloos and talk about population
War is
control.
not about population control.
That's
it's
it. That's
about
real
land
smart.
and territory, like it always was.
it's population.
It's all
It's
about the
land
money,
and
honey.
territory.
Nah.
It's
Hey,
like
all
full
about
Hey,
of
let me go
land
get
and
my
territory.
Indian buddy. We'll sit in front of a campfire and talk population control. Yeah.
They
I
want
don't
you to
think
think
so.
it's population control. That's a way of control, putting you in oppressed
Ugh.
modes.
Yeah.
No, it's about land and territory. That's what war is about. Land
No, it's
and
not.
territory. Yes, it is.
Control.
The control
It's
of
about
both land
control.
and territory.
You also have multi-billion-dollar corporations
This
that
land was
are
made for
only
you and
making
me.
profits when there's times of war too. So they like to, make the
That's
money.
that's why BlackRock control each and every one of the defense companies like Lockheed Martin and all that.
And it's
That's all
unfortunate
they
because
care
if you're
about.
public,
Yes,
if you're publicly
all you
traded or
gotta do-
beholden to a shareholder, that's legally binding.
Well,
All
that's
you got to
corporate
do
territory.
is follow,
there you go again.
follow the money. Follow
Territory.
the money.
Exactly.
Find out.
It's all about
Follow
it.
the money.
Go ahead
It's
and
not
try to
about
make a
science.
soda.
It's not about science.
it.
It's not about biology. It's not about pharmaceutical. It's not about entertainment. It's about money, man. That's all. That's all.
Again,
The-
Follow the money.
And for me, it's about these nice fat diodes.
Follow
Look
the
at
goal.
that.
I look like 2 amperes right there. No?
I like me a
Follow
fat
the
bottom.
goal.
Ben's only going one way, buddy. We get it.
Think about it.
You may not
Feelings
enter
of-
here.
Reciprocated.
money is paper, but what backs money is gold. It's follow the gold. Where is the gold going? That who's behind all
Oh,
it's
Well,
never
the gold, I heard that Bulgaria has sold all their Bitcoin
Oh.
for gold. Britain,
That's a 10X
Britain,
that.
I think Britain bought a bunch of gold now.
remember gold.
Anyway, we're going down a big rabbit hole here. We'll
No,
save
but
this
the
for
East has
we'll
been
pick it
buying
off.
gold, yeah.
We'll pick it off next Friday because I know we could go on with this for another 2 hours.
oh
But yeah,
man.
it is getting late. Next Friday, 9 o'clock Eastern. We do our live show again. Thanks again to chat. You guys were on fire tonight. That was really good. I tried to post as many of the messages I could on the main screen there. And don't forget to check out Old Man Builds. Don't forget to check out Benefactor. Also, Philip, your what is it, 4X?
For Knox.
4Knox.
For Knox, yeah.
Yeah, and Mike does his YouTube channel as well. Nathan and Ben, they do live shows throughout the week, so please check out their channel, subscribe, and share as well. And I also post all these shows that we do live on the Facebook news groups, so it helps generate a little bit more traffic for each of our guests on the show. And hopefully that gets the popularity up and gets. I'm starting to notice numbers getting better and better as far as how many people are tuning in, and that's good. So it's working. So we'll keep at it.
Right on.
All right, guys. Have a
Guys,
great
keep
night.
spreading the
Awesome.
word.
That's right. Subscribe, share,
Good night,
and
folks.
also support all these guys. Old Man Builds, Ben. Support everybody on this channel. And yeah, we'll be coming back live every couple of days. We'll be doing live shows. So, anyways, guys, thanks a lot. Have a great night.
Good night, all.
Thanks, guys.
All right.
Appreciate it.
Take it
Thanks,
easy.
everybody. Thanks, Mike.
Yeah,
Have a good
take
night,
care.
everybody.
Take care. Bye bye.